Hello, I'm Kelly Wanzer, the CEO of Luminus Networks, and we're here at the fantastic Tech Field Day Clubhouse, and we're talking about the future of monitoring networks. And we're here with the gracious support of Stephen Foskett and Tom Hollingsworth from Tech Field Day. And I have with me a really amazing panel of some of the leading experts in large-scale networking and some of the problems in this area. And I'm very excited to have them introduce themselves. And in doing that, I'd love it if each of you could talk a little bit about who you are and what you're passionate about.
Sure. I'm Truman Boyes, and I'm in the CTO office of Bloomberg Financial, and I'm the head of networks. So we're very, very interested, I'm very, very interested in cleaning up 30 years of networking and trying to simplify large-scale data problems and have global connectivity for market data.
I'm Cyrus Durgan. I'm the chief architect at Luminus Networks. My background primarily was at Amazon.com for about 14 years, and spent a lot of time doing a lot of different types of infrastructure-related projects, always on or around networks, obviously. I've always been passionate about computer networking as a technology since I was a kid. I think it's the fundamental thing that enables communication, enables businesses to grow and thrive, especially with the explosion of cloud and other modern computing and networking platforms. So I love being a part of that industry.
Great. I'm Nasser Ahmad. I'm part of the network team at Facebook. My passion, scale, and networking at scale primarily, where building networks is what I enjoy doing, but scale brings another element or another vector to building anything that you don't see anywhere else. You can build stuff at small scale, which is very, very different than building a very, very large scale environment. So the challenges are very, very interesting or different.
Awesome. And I'm Kelly, and my passion, for better or for worse, is enterprise IT. And specifically, I like big, deep, widespread, tier one critical technologies, preferably that consist of a lot of legacy technologies that are being used in ways that people never imagined decades ago. And how do we move that forward? Like, how do we get that ball forward? So on that note, let's talk about the problems. So I'd love it if you guys share how kind of your perspective on how you see the problems in networking and specifically in operations and visibility.
Yeah, I think to Najam's point, I think that the scale is the major factor. I mean, everything has a tipping point, and the way we've been building networks, they've grown organically. There's a major change in the way we're actually constructing our networks. There's a major change in the way that we're taking behavior that we've learned in the internet and now bringing it back into the data center. We're also realizing that it used to be hundreds of switches, then it goes to thousands of switches. Now we're talking about network elements, whether they're virtual or physical, that are going into the hundreds of thousands per data center. And I think that the piece which has been not entirely addressed as an industry has been trying to find, how do you find the needle in the haystack? So how do you find particular problems in either scaling issues or capacity problems or just service availability, and how do you detect this very quickly so that you can make the adjustments into your infrastructure before your customers call you because they've already experienced some kind of service outage? And in the financial space, I mean, more specific to us, we have a substantial amount of protocols or technologies that require fairness in market data. And so, you're dealing with the web side, which is, I think commodity, general networking stuff that you can address with, standard IP routing. And then you also have this other stuff, which is like the foundation of your business. And you have to find ways to kind of continue with legacy as you continue to move into, areas that you can actually solve with modern technology.
Cool.
You want me to go first?
Yeah, go for it.
Go for it, Najam.
the thing that we're trying to do at Facebook is change the paradigm a little. Where if you look at traditional network environments that are built, they're very people-centric, and a lot of the deployment and management and support and troubleshooting is done through people. One of the things that scale does is that it becomes really, really hard to scale with people, and it's just really not a very good way to solve that problem. So our philosophy is that we want to actually have robots run the network and people build the robots. So get people to focus more on building the robots that will actually eventually end up running the network. That's the tagline we've been using. And the whole concept is that the days of building a large-scale NOC where there are several people or dozen people sitting there watching monitors and looking at alerts, and when something goes wrong, they look at that and then try to troubleshoot, those days are gone at this scale. You'll need an army of people and a lot of different skill sets, and it's really, really hard to kind of do that. On top of that, philosophically, we build an environment where it's okay to fail, but you want to detect quickly and mitigate very, very quickly. So fail fast, detect quickly and mitigate quickly. That's really, really hard to do with people. So you have to do that with software. And that's the basic principle that we're using. And so we are not trying to build a NOC. We have a stated goal to not build a NOC. And we're at this stage where we have one on-call engineer that watches the entire network at any given time. And now it's a huge goal that we took on. It's a big challenge for us to get there. But at this stage, we have only one person that's on call watching the network. The rest is all done by software. And that particular goal that we took on essentially changed everything from our architecture to how we build things, to how we monitor things, to how we react to things, up and down the entire stack of building and running a network, building new technology to actually support that model. So that's been the biggest change in our environment. And if you think about this type of model, the biggest thing is to be able to detect failure and detect failure really, really quickly, and detect it to the point where it's an actionable event, that you get to an actionable event very, very quickly. And once you get there, then you know what to do. Then it's relatively easy to actually solve that problem if you've done the architecture right. So that's what we're focused on.
Awesome. Excellent. Cyrus, how do you think about it?
I mean, I see a lot of change, and it's a bit of a cliche, but change really is the only constant that I can refer to over the length of my career, right? And we saw a lot of change happen in the compute space, some fairly disruptive things. We're still seeing those things going on, VMs, containers, all these sorts of new technologies. A lot of the things that are starting to happen in the network space are very similar, parallel concepts. I think one of the things that you mentioned that was really interesting about, I've, way back when at Amazon, we had a NOC, right? And there were, 6 to 8 people that, they would do 8-hour shifts of sitting there watching the big wall full of monitors, and it looked really cool and space age and all that. But even back then, and this was well before, AWS, this was just retail, very, compared to today, very small operation. And even back then, with the limited number of resources that we had deployed compared to what an enterprise of that size would have today, it was almost impossible just to keep track of things, let alone actually do any sort of in-depth analysis or monitoring, right? So the first thing you have to know if you're going to be monitoring the database is, where is the database, right? And that, that model today with the more dynamic environments that people are building just absolutely doesn't fit the mold at all. So I think, the more dynamic nature of infrastructure is also a big sort of rising tide, I guess.
And so I have kind of a vector on this too, coming from outside of networking. And I started my career in data analytics. And so when I first started to get to know, and I was in email, where I was working with email in an open platform, and how do we operate email with software, right? And so it's like a baby version of the network problem. But it shares some attributes, and in email and some of these areas take you into marketing and ad serving and things like that, where there's this concept of data driven. And so you're used to these systems that are real-time feedback systems. It's like, it's a no-brainer. Like if you're in those areas. Yep. And when I started to get to know networking, like the very first thing I saw was like, wait a minute, that's how it works. And then looking at some of the new technologies early, like Arista with EOS and the emergence of SDN, where you could speak programmatically, seemed like a no-brainer. So the goal is to do like data-driven network operations, but at that time, people told me, don't say that. Don't say data-driven network operations. Say something else. but I think so for me the problem looks like such an opportunity because the solutions exist elsewhere. Networking is really thorny and hard and specialized and harder than people think. Yep. And it's getting more critical. Like what you guys do, the scale, the criticality, it's hard to explain to people how enormous and complex it is. So, but there's this wonderful, like, there are solutions to bring across, and so part of it is like a cultural blend, a skill blend, which is kind of that problem shaped. And so for me, that's really awesome. Like, wow, get to make something new in a team, and I know you guys know that because especially Najam, that's what you do. You build new kind of team to solve this problem. So
if you look at the networks industry, it's been a system integration industry, right? So network engineering has been mostly system integration, where we look at technology that is built by several different companies, we bring it in-house, connect it, interoperability testing and all of that, and we go deploy it. And then we run and manage it. That's a very classical system integration job.
Yeah.
And that needs to change into more of a network engineering, where you're actually building technology that fits what you're trying to solve, right?
Yeah.
And that actually changes the paradigm for the vendors to build technologies in a way that there are enough abstraction layers where people can actually build on top of it and extend it to their specific use case, rather than taking an appliance which does what it does. If it works for you, great. If it doesn't, you're sort of screwed in that you can't really do much with it. So you get into that sort of mode. So what we've been trying to do is change that paradigm and get to a point where network technology is built in a way that it's lots of abstraction layers, and then you can actually use any abstraction that you want and then build on top of it to the requirements that you have in your network and your philosophy to it.
That's really cool.
And it does require a huge skill set change. That's been the hardest thing to do, is to find the right set of people. When we started this journey 3 to 4 years ago, it was really hard to find a person who knew network protocols and software engineering.
Yeah.
If you look at the industry, it's mostly software engineers are working at vendors, building protocols, but they haven't really built or run networks. And if you go to the networks, there are people who have actually built and run networks, but they don't do software engineering other than scripting to that extent. Yep. And there's a big divide between the two sets of skill sets. How do we combine those two?
Yeah, I think you have the challenge of trying to find or build a team that has the right DNA. Where you have networking people that definitely understand software engineering. And we're actually starting to get to the point where we view switches and routers as effectively computers with 48 ports on them. So you treat them in a way which they're no longer special. There's nothing interesting about that particular switch. You don't care about the CLI. It's irrelevant. And then you start to take that same model and you realize that potentially the VLAN is irrelevant, then the IP address becomes irrelevant, and you're starting to move this model where actually the software stack continues to have more of the intelligence. The underlying transports become less of the focus, and I think that once we start thinking about having more intelligent applications, then the network itself becomes a little bit simpler. There's still a significant amount of intelligence that you do have to build for the monitoring capabilities into the network elements. And in the past, I think detection of network faults always happened in a reactive manner. And it's usually because a ping fails or a trace route doesn't reach its final destination. And we want to shift that model so that we know that there's something starting to go flaky before it actually happens, which I think is a much more sane model. And you can do this in standard software engineering, but if you apply that to a networking model, you start to marry these two worlds together.
Yeah. Oh, go ahead.
No, go.
Oh, I was just going to say. I mean, I think that one of the trends that that is sort of this like chocolate and peanut butter of network and application, right? That like they're sort of becoming more and more commingled. And to your point, I mean, I remember when I started at Amazon, my official title was a systems engineer. That meant a very specific thing. I worked on building out email and DNS servers and all that sort of stuff. For a while, my job title was network engineer, which was just because I didn't have a job title for security engineer. But I mean, the commingling of the skill sets that you need in order to run, build, and operate these kinds of systems is much more diverse than what we thought of as a network engineer 20 years ago, or a systems engineer 20 years ago, or a systems administrator 20 years ago. We don't, barely even have, and those job titles more or less don't really mean the same thing if they even exist anymore. It's, everybody is kind of, software and coding is the common language that people are using now to build these systems.
But as like the Reese's peanut butter cup yourself, because I mean, I just have to say, because it's a rare thing, but to have somebody who worked on the network at Amazon and then worked on hyperscale game systems. And so for us, like we think about these massive multiplayer game systems that are real-time feedback, high performance systems that take inputs from unknown variables out in the world, zap them through, and then you need to go backwards and forwards in time and see your gameplay and what was the state. There are a lot of comparable things to that, and some of the really cutting edge approaches to how you solve these problems over here, and then you have all the network context stuff over here, and it's a tough gig to do.
I think fundamentally, one of the lessons to be learned over the last, basically since the explosion of the internet, is that the applications are the things that really matter, right? The networks and all of these other things exist in order so that people can solve real world problems with an application, or entertain themselves with an application, or whatever it is. But it's the end goal is not to have an awesome network, right? We want to have an awesome network, and the reason that it is awesome is because it enables all this other awesomeness to happen.
Because you never notice it.
Right. Well, yeah, and it's the tree falling in the forest kind of a thing, right? If a packet falls off a network nobody cares about, did it really fall? I don't know where that goes, but and so I think just to kind of toot our own horn, I guess, a little bit. I think we've done a really great job of bringing a lot of those different disciplines to bear to think about this problem as we've been, working through and building our product. And people from, Kelly mentioned the large-scale gaming backgrounds, people from biologic computing, very diverse set of people, and people from the actual hardware vendors who know the gear inside and out, and can bring that level of detail and insight into the systems that we build. And I think that's critical. I think that's what all the sort of the future of infrastructure teams is going to look like.
And we're all kind of modeled after Najam.
I hope not, because I want to learn from people too on what they're building. There are lots of people building really cool stuff.
Yeah. I mean, our job is to make it repeatable, but you've built it, or you've begun a really, to set the.
It's if you think about what you were sort of talking about, the application versus the network. If you take it down one level, there's a network that provides a service, but there's such a hard boundary between applications and networks today. How many enterprises have this statement that runs around, oh, must be the network?
Yeah, the network is down.
Exactly. When the application is seeing some sort of problem, they can't troubleshoot, it must be the network.
Yep.
How do you solve that problem, right? So one of my pet peeves is, in the network world, it's really, really hard to say what is normal. when if somebody says, hey, is the network working okay? How do you answer that question? Yes, the network's normal or not. It's really difficult to answer that very simple question. Most services will tell you, if you look at an application, we have a bunch of parameters, transaction latency, connections per second, blah, blah, blah. There's a bunch of things you measure, and you say, yes, the service is running normal for this time of day, for this day, in this year. Great. There's no such thing as network that does that normal. So if there's a problem, how do you know there's a problem, right? And so we've been relying a lot on the bottoms up troubleshooting. When an app sees a problem and they can't solve it, they can't figure it out, then we go look at something. I'm not talking about the obvious stuff where if a link is dropping packets, lots of CRCs, that's easy to detect, that's no big deal, right? But there are the real weird cases when the application is seeing something and there's some interface somewhere silently dropping packets. How do you find those, right? And there's really no way to sort of drill down and figure that out. So one of the things that in the monitoring space needs to happen is that we go up away from this bottoms up troubleshooting where when something's broken, then a network engineer gets in and logs into a bunch of devices and tries to figure out what's going on, try to detect the path and check the path and all that. One, there are just too many devices to do that. Try opening 100 shells to log into 100 devices to kind of go figure that out. It's just not possible. It takes too long, right? So one of the approaches we're taking is that we have a lot of data that we collect from the network itself, and then we started to build this heat map, which is supposed to be green all the time, but it turns yellow in different spots. And then you can double click on that yellow and then sort of drill down and figure out what's going on. So you're sort of really pinpointing where the problem might be. And this is without the context of an application is seeing a problem.
Right.
It's the network knows that this is my normal, and something here is not normal. And let's go troubleshoot that. So to your point on how do we get proactive about this is trending towards a problem, and building that hysteresis to be able to say this is normal and this is not normal for today. What changed?
That's cool.
That's the kind of technology we need to build in monitoring
And
space.
is that how you think about it, Truman?
Yeah, I mean, I feel like some of the answers have actually been under our nose the whole time. Look at the archaic technologies that we have been using for network monitoring over the last 25 years, and some of them, in terms of even the whole ecosystem of network monitoring companies, they're continuing to whether it's syslog or SNMP or technologies that we know how to build better messaging systems with reliable transmission that give us real-time feeds. And another thing we know is that microbursts are real, and so when a 9:30 market open event happens and you have mass sell-off or buy of lately it's been a sell-off, but it's quite interesting because you do occasionally have black swan events where you have your baseline of networking and then all of a sudden things are totally different, and you need to know how different and where is it different, and is it just in your multicast traffic or is it also in your unicast traffic. And so I think a couple things that need to be really kind of highlighted. One is significant investments or changes in the ecosystem in the monitoring space that actually use modern technologies to distribute the performance metrics. The way we're doing it today is a very reactive approach, and I think that what we're embarking on is I want to know immediately what's happening, what's my utilization. And to deal with these microbursts, I need resolution it's accurate down to the chip level. I can't poll it every 5 minutes or 1 minute or 1 second. It's just, that doesn't scale. Now take that problem and bring that out to, thousands of switches. Now I have some other data collection problems. So we have to solve the data collection side. We need to solve getting the most accurate resolution of the individual metrics. And then also I want to have the ability to have performance analysis and all the debugging performed automatically. I mean, there should never be a situation that you have to open 100 shells. I don't even think you should have to log into switches at all. I think that this is much more, a broader approach where we think about it in a programmatic way, where we're doing API connectivity And we're asking much more abstract, high-level concepts like, is my network okay in Jakarta? And what does that mean? And that could be based upon service availability. It could be, is there reachability? And then, I think the other pieces that have to be cleaned up are, just kind of the data collection side of it. How do you ask these really hard problems of massive sets of data? Like, many networks, I know plenty of operators that have turned off their logging levels because it's just too much. They don't.
Too much noise.
Yeah, it's too much noise. And how do you find that little needle in the haystack? So I think that's an area that I think we're starting to tackle. Companies like yours, like Luminus, I think start to peel away at this problem, and I think there's an opportunity to see greater adoption in new changes in the switches, where the switches actually have agents. I think are actually a really, really smart idea, in that you can have a more of a distributed software approach to solving network problems.
Cool. Is that how you think about it, Nizam?
That's something that we've been pushing and doing for a while. I think I'm on record saying SNMP is dead. Long live SNMP. It just doesn't scale for the environments that we have. We want down to the millisecond, not down to the even second at some point in some environments. And the amount of data that you get, so try to gather 100 gig interface and try to gather 1 second of data, that's a lot of data. And trying to get that to some machine and then compute it just doesn't work. So agent running on the device itself, gathering a certain set of data, massaging it, munching it, summarizing it, and then sending it off is a much more scalable model. The other thing that it does allow us to do very rapidly is in sort of running a large network, you always run into new scenarios, things you've not seen before, right? And that's really the cool part. Is like, can you react to something you haven't seen before?
Right.
And how quickly can you actually do this? So one of the things that does happen is when you find something, hey, it'd be great to get this one particular stat out. And if you know the chipset enough, then you can gather that stat directly from the chipset and very quickly start summarizing and sending that data back out, and not have to even wait for a 5-minute polling cycle to know if your problem still exists or not. Right? So it's all about, again, the quick detection and quick mitigation of it. Right? So the longer it takes, if you have to wait for 2 polling cycles to determine if your problem still exists or doesn't, that's 10 minutes. That's an eternity in our world, right? We want to fix the problem in 10 seconds, sort of the human comprehension problem, right?
Right.
What does humans comprehend? 10 minutes, and every human being figures out something's broken.
Yeah, I mean, just also to add on to that, I think that the way that we're being told to build networks is to use lots and lots of links. So we're starting to scale out with equal cost multipath, and just imagine situations where where you don't have a fast fail, where you actually have like 0.05% packet loss on an individual 100 gig interface. And how do you determine which member interface out of 32 ECMP? Like, how do you find that? And these are the things that really, really concern data center networking. I think you have to have the intelligence, you have to have it in your switch, and you have to have summary data, which is then kind of taking that and reporting it back to a higher level abstraction. These types of problems do happen, and when they catch us by surprise, I don't think that the standard tools that ping, trace route, whether it's even logging into individual devices, at that point you're into the hours of outage, and when we have minutes of outage, it actually affects the market. So it has our concern is how do you deal with this immediately, and how do you always have a reporting structure that's going back to a centralized view? So I think that the heat map idea makes a lot of sense. Being able to kind of see your entire holistic network at a top level, and then drill down to the appropriate offending part.
Mm-hmm. Yeah, I think that you both have raised a lot of really awesome points. I guess my comment would just be that you guys both run enormous networks that I think could reasonably be described as critical infrastructure for just about everybody. And I really love the passion that you guys bring to the subject, and a lot of what you're saying, your point about people sort of trimming down or even disabling logging on devices, it drives me nuts, because because these are all these great big interlocking, interconnected, interdependent systems, it's very rare that a single problem will cause, like, say, a global outage or something like that, right? You have something starts to go wrong over here and it starts to get worse and it starts to spread and load and queues fill up and things start to drop packets, and drop packets means no business. And so the point is that if you're getting that super granular, high resolution, high frequency data, and you're able to report or even better act on it locally, autonomously, you can oftentimes prevent something that would grow into a really major serious. So it's sort of a blast radius containment, as well as, you know, being able to pinpoint it on the heat map. Where is it, and how bad is it, and can we prevent it from getting worse?
Yep.
And you guys have sparked several trees of places I want to go. So the first place is just a comment, which is part of the reason that we're here is, you know, even though you guys have large critical infrastructure networks, we're seeing, like, if you're responsible for a network down to, like, I've got a, you know, we've got one customer who's a, you know, it's a microchip company in Texas, not a massive network, but man, this kind of tool he's been dreaming of, you know, where he can see everything in real time and it's all unified and it's all modeled out.
Yep.
But Najam raised the point in his comments about being able to, you know, something different is happening now, I can open up a new data source, or is the elasticity required?
I mean, this is how technology is built is changing, where technology was built more from an appliance point of view, that appliance comes in, it does a bunch of things. Here are the SNMP MIBs that are published as part of the release, and you get what you get, right? And that is not very conducive to an iteratively improving model, because then the iteration takes months and weeks and code rolls and all sorts of stuff like that. What we want to see more of is that the data that any particular hardware or a system can collect is available. You can choose to collect it or not collect it and do it on the fly, right? So provide us interfaces that allow us to get to any data that is available on that system down to the chip level. So no more custom ASIC. If you have a custom ASIC, better publisher SDK, show us what you have in there, right? So that we can actually get down to that level and say, hey, I want to see the queue depth of every VO queue in this system, because some queues getting too big, causing latency, we need to figure this out. Can't do that, right? So if you give us that ability to actually get to any data that is part of that system, then it becomes our choice to say, I want to collect this or not collect this. I want to collect this often and collect this certain other things that often, and build an agent and then change the agent on the fly, right? As we discover problems. So it really becomes about building technology that one has very good programmatic APIs to get to the data that is available, and then building different abstraction layers that gives you different level of information. This doesn't mean that don't build a visualization tool.
Right.
Yes, visualization tools may be good for some smaller environments, some other enterprises that may not have the software skills to do it, or for certain simple applications. But then build other abstraction layers that other people building networks can tap in at different levels, right? So you're really just re-architecting your software stack or your technology stack to build abstraction layers that different companies can use at different layers and be able to leverage that capability, right? No more one size fits all with one CLI or one SNMP interface. That's really the point.
I mean, I wanted to comment on it. Before you had the statement of, SNMP should die, and I think that one of the main reasons why this needs to be echoed in the entire industry is that, like, SNMP as simple network management protocol is totally an oxymoron. I mean, it's not simple, and it's not a management protocol. It's terrible, and one of the main things, like, first of all, it's a binary stream of, like, ASN kind of format. Nobody understands it. You have to have protocol decoders to make sense of it. It's just terrible. It needs to die, and I hope that vendors actually realize that we don't want to consume it anymore. The other thing about it is, like, the inefficiencies of iterative steps. So, you get some MIB and you have to query, first give me the, if index of this particular, MIB. Okay, now I got that OID, now I need to query this next thing. It takes me like 30 steps to find one variable.
Yep.
When I really just want to ask the chip directly, like, what's your VOQ buffer? And I should be able to do that instead of having to wait for the next iteration of the new SNMP MIB so I think these technologies, we need to, as anyone who's in the consumer side of it, we need to tell the vendors we don't want more technology that's continuing to be built upon these archaic technologies. The other second part is, direct access to the chips is a requirement that we have to have from the vendors. Like, we need that, and the reason is it actually creates a common platform or a common level of access to our destiny, actually. I mean, I don't want to get tied up in waiting for the roadmap. Okay, in the next 6 months, I'll finally get the patch to this particular version. Mm-hmm. I think that the tables have turned pretty dramatically. I mean, you have all these initiatives, whether it's the OCP side within hardware and the all the networking innovations that have happened over the last 3 years. I mean, SDN as a whole, I think it's been very interesting because it's raised the right questions. Some parts will actually, come to fruition, but the one thing which still, every time we talk about SDN in the networking industry, it's about connectivity. And the piece that has not been picked up, with enough emphasis is how do you deal with this 25-year-old management problem? These networks are not going, they're growing in mass scale. And anyone who wants to operate a large scale DC or just enterprise IT, kind of large worldwide deployment. For us, it's, massive, presence in 184 countries and, backbones, and we're not typical. But the standard enterprise, let's say, their standard Fortune 500, they still have some data center presence. And how do they manage that? How do they get the SLAs that we're talking about trying to achieve within, market data companies or in content companies? I think that they're looking for the same thing. We all want to get the most number of nines in our SLA. So we have to find, tools that actually allow us to achieve that.
You have a high 9 standard.
Yeah, as many as possible.
Yeah. And Nizam, you touched on the programmatic aspect too. And I know, Truman, that's been something you commented on before. But in terms of, so we sort of talked about the bottom half of the system, which is, how do we interface with the network to get data in where we can have high resolution and scale, or dynamic resolution and scale. And then the top of the system is, I want to be able to code to it. So it's abstracting now the data on what's happening, and I want to be able to code to it. And what do you guys do at Facebook? What kinds of things are you building? We know you have a heat map, so that's cool. First app, yeah.
The focus that we have is to, at least from an operational perspective, is to be able to detect a failure and then mitigate it through software. So for example, a line card fails in the system, there's software to detect it, and you get enough alarms when line cards go down.
Yeah.
And then there's an algorithm to determine if there's impact of this line card being down or not, or certain ports on being down. And if there isn't enough capacity, then yes, sure, some human being will get involved. But if there's enough capacity, we will simply drain that line card or drain that whole chassis. And just drain that device, and then open a ticket to site services to replace it or check it out next week, right? So, and then no human being gets involved in that process. So the way you get to a point where only one network engineer is watching the network is that when things fail, that network engineer is not dropping everything and going fixing something, right? So the concept is detected and then being able to take it offline and then open a ticket somewhere else to go deal with it, right? But that also means that architecturally you need to support it, right?
Yes.
So if you look at your classical network architecture of 3 tiers, primary, secondary, that just doesn't work, right? Because if primary fails, you better drop everything and fix it, because the secondary goes, you're done, you're dead, right? So this is what you were talking about, wide ECMP, right? We're 16 wide. So in our data center, we're 16 wide and spray the traffic across. Now, if one goes, who cares? 1/16. If two goes, who cares? 1/8. Yeah, sure, we'll lose 1/8 and be happy with every day. Not a big deal. So in that environment, if a switch is misbehaving, a port's misbehaving, we'll just drain it and leave it alone. And then next day, 2 days later, a week later, somebody will go figure out what that looks like and why it's failing. So that ability to be able to do that is what's really, really important for us to be able to scale with software. So every time you get a new alert, what do you do with it?
Yeah.
And that's what we're looking to build.
One of the things I think is interesting is for companies like yours that more or less, are entirely dependent on the network being up in order to do what you do, is that one of the things that I think makes the traditional approach to IT engineering sort of non-functional is that you can no longer afford to do the root cause analysis during the outage. Right? You can't say we'll just leave the network down while we kind of go around here and try and figure out what's really going on. Right? It's like drain the traffic, shift it, roll it over to a different device, get the site back up or get the service back up, whatever it is. And so you lose, with the traditional monitoring tools, of polling SNMP or what have you, you lose that ability to sort of go back in time and say okay, we don't want this to happen, so let's figure out what it was. We rolled the traffic away from it, so it didn't impact anything, but we still want to know what happened, right? And if it wasn't something like a hardware failure, that it is more or less a permanent problem you can look at and identify, it can be very challenging. Now, how do you guys sort of approach that? What do you have thoughts on sort of how modern monitoring systems would enable you to sort of do that?
Yeah, so that's actually a really key point. And what happens when you have a problem and you just drain the traffic and now you don't know what the problem was. So a couple of things. By design, we want to get to the point where we don't troubleshoot config, especially in the data center world, right? We treat the network device much like a server. If it's misbehaving, flatten it, rebuild it, see what happens, right? So config is an image rather than individual lines being checked, right? So you take one variable out saying configuration is not the problem. But that also means that you have configuration at a topology level. You know that this device sits here in the topology. Based on that, this is the config for this device. And oh, by the way, that's an image, not a per line config, right? So that's one variable completely out that nobody went in and changed the config that's caused this problem, right? Then the other thing that you have to do is collect enough data that you're collecting all the time so that when the problem happens that you hopefully have some anomaly that you figured out in that data that will point you back to this something happened. And in that and then you also worry about hardware and saying if it was a hardware problem. So people worry about hey, why you build your own switches and it must be because of cost. I'm like, not really. One of the reasons why we do this is where we want to make that a point where one, we can go 16 wide, so it can be a lot of them. So we don't care about failure. And two, we can just take it out, put a new one in to see if the hardware was a problem. Right? So you're essentially reducing the number of variables and you're collecting enough data in the hopes that you will be able to offline figure out what the problem was.
Makes sense.
I think one of the key points is that we're not hand building. We don't have artisan handcrafted configurations from Williamsburg. It's not. These aren't hand built.
Vintage.
Exactly.
Pennsylvania Dutch switch config.
This is not. It's not home built. I think what we really want to have is a declarative language that you use to kind of specify intent. So you can say I want my network to look like this. It's either like an A, a B, or a C, and for that role, for that level of config in the hierarchy. The one thing which we haven't entirely said, very loud, is that the only thing which is allowing us to achieve this, or one of the major key points, is that software applications are changing, so that we're able to drain things. A rack. Let's say I lose 32 machines in a particular rack. I can do that because the applications or the operating systems, all of that, are not being so special. It's not this, this machine that's like the one web server that's, serving up this part of the company. You're starting to distribute this and kind of spray it all around your infrastructure.
Yep.
So, to the point of actually troubleshooting, many parts of the network we can leave in a semi-broken state, and you can, at that point, either have vendors, get into the equipment and start to troubleshoot it deeper. But I like the approach that you effectively rebuild and try it again. And so parts of your infrastructure become low touch, but in the event of failure, you just cycle them till you get back to a nice, known steady state. Because the effort required to continue to troubleshoot thousands of switches or try to troubleshoot individual, let's say, forwarding plane related issues, it's just not worth our time. And especially when you're looking at effectively, commodity switching in some places, and in other places, particular roles of devices that you can swap out and put a new one in. And we're thinking the same way applies also in the server world, that, if you have servers that fail, that you turn them off, and you don't try and find out why does that NIC keep flapping up and down. Just deal with it later.
Get a new one.
Yeah.
So, unfortunately, because this is really fun, I could keep going for a while, but when we might. I don't know. I'll have to ask the host if we have time for questions. But I wanted to touch on kind of one last concept, because we talked about the data collection and having something programmatic in terms of that unified view, and something elastic that allows you to pull in new types of data and different sources and devices, and hopefully it's all standards-based and directly from the horse's mouth. Okay.
Be transparent and open, and you can make it a standard later. We'll be fine with it.
Yeah.
Okay, perfect.
Don't give us an opaque interface.
We think that too, actually. So we're happy to normalize it. That's fine.
We just don't like opaque interfaces.
Yep.
Gotcha. Yeah. So, but the one piece that we haven't touched on too much that I kind of find fascinating about the network problem is if I want to answer the question of, like, could traffic from this application go from this VM to this VM? And if not, what's wrong? And I may need to answer that question from 4 p.m. Tuesday. So I want to roll back and see that. There's this issue of kind of dynamically modeling the network.
To kind of steal a term from Marcus J. Ranum back in the past, there was like, having a network flight recorder, that it makes a lot of sense to be able to go back in time and see different save states, I think is highly critical. So, having time series databases of eventing, I think, is essential. The other piece to it is, you're looking at, to your point, you're looking at how do I get from one location to another location, and was there reachability between them?
Yeah.
I think that you always need to have visibility of a forwarding path. So, whether that's from RIB or whether that's from FIB or both, maybe a combined view, I think is essential to effectively play back. This is one of the problems that if you have transient network problems, whether it's oscillation of a routing protocol, it's really, really hard, especially on the internet. We have internet connected customers, and it could be 5 ASs away, a particular prefix pops up and then it goes away. I want to know about that. I want to know about it from a security point of view. I want to know about it from reachability and SLAs. So I think being able to capture that and have to your point, like actual time series data is a requirement.
I'll be honest, really hard problem to solve. At our scale, there's just no way you can actually have that much time series data. So we're not actually attempting to do it. It's easier to do it at a control plane level, because you can still record what your routing looked like, but the actual data path, it's really, really difficult to actually have that level of data. So that's something that we're trying to solve at that level. What we're using is a slightly different approach, especially from a user perspective, because we do have the other problem of we have a very global user base, right? Mm-hmm. So 82% of our users are outside the US. So that's a pretty stark stat that you think about it. It's like majority of your problem is outside the US. So if there's a user sitting in Indonesia on his smartphone, what performance are they getting? Mm-hmm. How do we know? Mm-hmm. How do we know they're having a really awesome experience or a really crappy experience? Mm-hmm. And the next question is, even if you know, then what can you do about it?
Right.
And those are really both hard problems to solve. Right. So I think a lot of this stuff, at least in our kind of user base environment, needs to come from the client level as well, right? So if you look at like the modern browsers, Chrome does that, gives you a lot of stats about TCP setup times, first byte in times, stuff like that. So you can actually look at the actual TCP performance. So we're building some technology on the client side as well to give us the same level of stats to get a per user. So it's really cool to see that a set of users are seeing a certain problem, right? Now you can then start doing the correlation saying, hey, this set of users behind this ASN is seeing similar level of performance. Hey, can we just move them to a different ASN and see if that gets better?
Gotcha.
So we're kind of taking that approach. Otherwise, our traffic volumes are just entirely too big to do any sort of time series. Our Hadoop costs will just go through the roof. We won't be able to talk about
Cyrus,
them.
maybe to Najam's point, you could talk a little bit about, he made the comment about you can get some of the data from the control plane. What data what's the art of the possible here?
We look at every interface we possibly can. I mean, that's kind of my passion is like, poke the chip from all directions possible and then do correlation and see if it's, kind of spitting out the same answers. So, control plane, data plane, diving directly into the chipset where available, that's awesome. The vendors have started to provide some pretty decent programmatic access, whether it's, RESTful APIs sitting on a web server on the box or an SDK that runs natively on the switch. I hate to say it, but, there are still some dusty corners where SNMP or CLI scraping is still the sad but only answer available. And I joined forces with the Death to SNMP army, and I hope that all that goes away sooner than later. The simple fact is that it's, like Truman said, it's not simple. There's nothing simple about it. It's designed by committee from years before we had networks that were even capable of the sort of volume of bandwidth that we have now, the incredibly low latencies that we can achieve, and it's just everything has scaled out beyond it. So, but in terms of the ways that we can get data, we can run natively on the platforms that support that. We can do remote, either event-driven or polling-based things. We're very flexible in that sense. We want to have as many ways to cross-validate and correlate the data that we're seeing, so that we can spot some of these very tricky, hard to find anomalies. Like you said, an entire line card blown out, you're going to notice that. that's not a hard problem to find or detect or fix. We want to go after the needles in the haystack, and to your point about turning off logging, that sort of thing, that's just throwing the whole haystack out the window. It's if you don't have any hay, you're not going to find any needles in haystacks. So you gotta have a decent amount of hay. So that's kind of where we're at.
Well, on that note, let's go make hay. It's time for dinner. So I really want to thank you guys. This is a great dialogue, and really appreciate you guys sharing your experience from the perspective of critical infrastructure and cutting edge. And thanks, Stephen and Tom, for hosting. And we'll look forward to next episode when we'll say our thorniest network issues. All right, thanks, guys.
Great, thank you.